Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to discuss about finite mixture FEMIX model in SmartPLS. Basically, we are having two types of heterogeneity. One is observed and another is unobserved. So when I talk about observed heterogeneity, or rather the heterogeneity means that is there any significant difference in the model in two groups or not? For example, is the models significantly different in male and female according to the group wise, according to the country of the origin, or is the model significantly different in public limited or private limited? So when we are clear, the researcher is clear at the time of the questionnaire only that possibly this can be the reason of the heterogeneity, then it is known as a observed heterogeneity. But there is another case also, that there is an unobserved heterogeneity, or that is, you can say, an undercurrent which is passing in the model, about which the researcher is completely unaware. He is not aware that this can be the reasons of the significant difference in the model. Now we are having the age old techniques, that is a clustering techniques. We are having it in which we specify the k-means, and that's the way we go ahead by specifying the k-means, and then we run the model. But there are some flaws in this. The flaws is that cluster analysis is only capable to do the segmentation, or rather it cannot be applied on the path model. So here we are dealing with the path model, and therefore it's not possible to run the cluster analysis, and that's a basic flaw in that. Now, according to the Becker, failure to consider unobserved heterogeneity can be a very serious threat to the validity of the model, and we should do the accountability of unobserved heterogeneity. Now, this we have seen in PLSM. PLSM has proposed a multitude of specific methods to identify and treat unobserved heterogeneity. Now here when I say multitude of specific methods, there are two methods which work on identifying unobserved heterogeneity. One is FIMIX and another is a POS, that is a predicted oriented segmentation. FIMIX works very well on the structural model, but it's not possible for it to identify heterogeneity on the measurement model, and therefore predicted oriented segmentation POS can work very well on measurement model. FIMIX, it's really good for the reflective construct. POS can work on reflective also and formative also. When we'll be talking about predicted oriented segmentation, we will see the difference which exists in both these techniques, but these are two latent class techniques which have been developed for observing unobserved heterogeneity. Now, according to the hair, see, this is a full set of data in which y1 and y3 is 0.30, p23 is y is also 0.30. When I divide this model into two parts, group 1 and group 2, you can see in y1 to y3 what we get is 0.50, and in y2 to y3 we get 0.10. Similarly, in case of group 2, what we get is y1 to y3 is 0.1 and y2 to y3 is 0.5. Right? You can see the difference exists in these two groups. Now, if we fail to recognize the heterogeneity in above example between these groups and analyze the model, we are doing the model is substantially biased and we cannot accept the results. So, the solution is FIMIX. Originally, the FIMIX was developed by Han et al. In 2002 and it was later extended by Sarstedt in 2011, and it is considered to be the best latent class approach till present. Now, what we are actually doing in this, according to the words of the author, we are disentangled. That is, we are unearthing or mining mining the distribution which is existing in the model. So if there is an overall mixture distribution which is there, we are trying to find out the segment specific distribution which is existing in the data or not. You can see the mixture distribution is there, and then we are trying to find out segment specific distribution. You will have to run the FIMIX PLS procedure, determine number of segments. Step 1 is FIMIX PLS procedure. Step 2, determine the number of segments. Step 3, explanation of latent segment structure. Step 4, estimate segment specific models. This we will see one by one. Run the FIMIX PLS procedure. Here you will have to run FIMIX PLS algorithm for alternating number of segments. That is for segment 1, 2, 3. How many segment, that is, you will have to decide that for how many segments you want to run the FIMIX. And all these segments will be compared. But for that, you will have to determine minimum number of segments. Step 2 is you will have to determine minimum number of segments which you will have to run. So according to Hare et al. 2016, he has specified that defining a range of segment solutions to consider is a FIMIX PLS analysis. The theoretically maximum number of segments is given by the largest integer when dividing the sample size n by the minimum sample size n mean. This we will explain. See how it goes this way. There are two methods to it, right? We will see the first method. Find out the construct which is having maximum number of items, right? So let me activate this thing, maximum number of items. I will go here and I will activate this thing, extended model. Now this construct is having maximum number of items 8. Let's go back on the word file. Multiply it by 5. So 8 into 5, 40. Minimum cluster size is 40. Minimum number of segments. What is the sample size? It is 200. We very well know that in this data, in this original data which is there, the sample size is 200. So what I'll do is, I'll just divide 200 by 40. So you will have to work on 5 clusters. This is the first method to identify how many minimum number of segments you will have to run. The second method is by using G power. So I'll activate the G power here. I'll have to go here in G power. I'll have to specify that I want to run for linear fixed model regression coefficient 2 tail 0.80, that is the statistical power should be 80, calculate. So it gives me the sample size as 55. You can see here it is 55. Okay, let's go back and try to work on our data from the data file on which we are working from our first video. Let us activate this demo. Here you can see that maximum number of items on each construct is 4. Let us go back on the calculations again, how many segments we have to run. So maximum is 4, 4 into 5, 20, minimum cluster size is 20. According to G power, we are getting 55 and the number of samples are 400. So 400 divided by 55 is 8. So we will have to run FIMIX 8 times. There are some criterions which we will have to understand. The criterions are, while running the FIMIX PLS algorithm, these are the criterions. Use a stop criterion of 1.10 raised to minus 10 and a maximum number of 5000 iterations. Okay. Use 10 repetitions to avoid convergence in local optima. So 10 will be specified. Use the indicators having missing values. Do not use mean value replacement or any other imputation methods. This we will have to do it. Then last, run the FIMIX one by one for 5 or 8 segments depending upon what you have got according to those methods. So now we will have to run this in SmartPLS. So we will go here and calculate FIMIX. Make this as 1 and 10. Start the calculation. Now you will get here the fit indices. This fit indices you will have to copy on the Excel and you will have to take it in Excel file, Control V. Now specify this thing as cluster 1. Specify this thing as cluster 1. Now you will have to run this analysis of FIMIX. Go and calculate FIMIX for cluster 2, 3, 4, 5, 6, 7 and 8. You will have to run for it, right? So let us see what we get for cluster 2. Now the results are ready for 5 clusters. I'll maximize it. and you will be able to see. The decision of which cluster solution is better will be depending upon this criterions, this 11 criterions. Smaller the better. In each criterion, smaller is the better. One, you can see here, according to AIC, cluster 4 is best. According to AIC 3, cluster 3 is better. AIC 4, BIC, CAIC, Hanan Quinen criterion. This is consistent AIC. This is minimum description lag. This is log likelihood, entropy statistics. So all are giving different results. Now what to do? Which is the best decision to take? So there is some guideline which we will have to follow. Determining the number of segments. The first is, if AIC3 and CIC indicate the same number of segments, choose this solution. If they are showing this, that pick up this, that's best. Alternatively, jointly consider AIC3 and BIC. Also consider segment number as indicated by AIC4 and BIC. Generally, choose fewer segments than indicated by AIC and more segments than indicated by MDL5. So what it says? Choose more segments in comparison to AIC and lesser than compared to MDL. Now, when there is too much confusion, there is one blanket rule. The blanket rule is choose the cluster solution which is having entropy higher than 0.5. Let's see where it is. Directly go here and find out in entropy which cluster solution is having entropy more than 0.5. You will come to know cluster 2 is much better, and therefore you will take this cluster 2 solution for our data. Okay, let's go back. Now you will have to rerun FIMIX. This time make it 2 because we have identified that the 2 segment solution is better. Start the calculation. It will take some time. Now the results are ready. You can go in segment assignment and you can see segment 1 and segment 2 has been identified. Now we want that both this thing should be stacked. So I'll go in discrete segment assignment and you can see that the case 1 has been identified in segment 1 and case number 13 has been identified in segment 2. Now this heterogeneity is according to the software which has been identified by the FEMIX algorithm. Now we want this heterogeneity to be introduced in our raw data. I again repeat, this is a heterogeneity on its own. It will not assign this heterogeneity into your data file. We will have to assign this heterogeneity manually. We will have to assign it. So what I'll do, I'll copy this to the clipboard. I'll click here and then I will go in this original raw data file. I'll go at the fag end and I'll just click here and do Control V or paste it. So now in my original data file, the partition is ready. Once this is done, I will again go back on my data file, on my canvas, and what I'll do is I'll import the data file. Import the data file. I have named that data file as partition. Click OK, open. Click OK. Once this is done, now this partition will be ready here. Can you see this? This partition is ready. Now let us try to go in the raw file, in this data file, and generate the data groups. I will name this as partition. Activate it. Final partition. This is according to the software. We don't know what can be this unobserved heterogeneity. Click OK. And you can see that in this partition, 382 records are in first partition and in second, 18 records are there. We are not aware about this, that what is the reason for this bifurcation. So what I'll do is I'll go in again original SPSS file, or rather data file, and here I'll try to run analysis descriptive statistics for all the grouping variable. So C1, C2, C3, click OK. Not descriptives, I will go in frequency, analyze descriptive statistics and frequencies. So I'll activate C1, C2, C3 and click OK. Now here you can say male and female 200 records are there and 200 records are there. So I think that the unobserved heterogeneity is not coming from here. Here employee type class 191 and 209. I think that this can be one of the reasons where heterogeneity is getting introduced. This can be one of the reasons. So uh, we will introduce this in our model, right? And geographic location, again, same thing, 200, 200. So heterogeneity cannot be because of this reason. So let us introduce the employee type class heterogeneity in our model. Let us go back. Again, generate the data groups. And we know that C2 is the employee class type. So I'll write down here as employee class. And C2 is activated. Click OK. So here, let us see what 1 stands for. Let us see what 2 stands for. Go in the data file. C2, 0 stands for part-time and 1 stands for full-time. Let us assign the values. So edit, 0 stands for part-time. Click OK. Here 1 stands for full-time. Click OK. So there are two types of heterogeneity which are there. One is system developed, this, and another is manually, which we have done. Now our objective is to match the results of the heterogeneity absorbed by the system with manual. We will have to match it manually. How we'll do? Again, we'll go in demo. This time calculate bootstrapping. And in data groups, we will run first partition. For partition 1 and 2, start the calculation. Now we have got the results of path coefficients. You can see complete partition 1. You go in demo, and here also you can see both the models. Here partition 2 is not being shown because it is insignificant. 18 records are only there, and that's the reason it may not be showing. Otherwise you will say you will get both the partition 1 and 2. Now what your objective is that you will have to compare this results of bootstrapping, this path coefficients, with which is done manually. So again go back, calculate bootstrapping. That was a system identified heterogeneity. Now case manually, which we have identified full-time and part-time, and we will start the calculation. Now this time you will get the results of full-time and part-time. Both the results will be there. You can go in your demo file and you can see this thing from here also, part-time and full-time. Now, what's your ultimate objective? According to the authors, what they have said, you will have to manually assign the segments, that is part-time and full-time, which we have got it. We are trying to compare with the system-specific segmentation which has been done. After that, you will have to compare the results of both by system and by manually. How you can compare? So for that, you will have to use this Excel sheet reporting the FIMIX. I'll expand this. So the complete partition 1 and partition 2, employee type and employee type 2, the original sample, that is the path coefficient when it's complete model, when second construct, third construct and fourth construct, you will have to report the p-values. You will have to report the p-values after the partition. For this is a system specific partition which has been done, and employee type 1 and 2, you will have to report reflective measures, If it is a reflective scale, you will have to report Cronbach alpha, rho, composite reliability, and AVE. If it is a formative measures, you will have to report conversion validity, VIF, and p value, overall R square, and overall R square of the staying intention, explanatory power of the model. So this is all about explaining the unobserved heterogeneity in the model. Thank you. You can subscribe to my channel. You can follow me on LinkedIn and Twitter.